One last little thing we're going to add to compound events. We're going to use complements with compound events. But let's first start by refreshing ourselves on what compound events kind of look like. So we're asked to find the probability of drawing a red card, a heart or a diamond, or a face card. So we're going to do the probability of a red or a face. Now, let me actually use proper notation there. Let's use the union symbol, a face card. So we're going to do the probability, my goodness, I'm having a hard time writing. The probability of a red card plus the probability of a face card minus the probability that we get a red card and a face card at the same time. So red cards, there are a total of 26. Now I'd strongly suggest you leave these unreduced because yeah, half the deck is red cards. Then face cards, well there's 3 in each suit, so that means there are 12 total if you're just doing jack, queen, and king. We're not including aces out of the 52. And then of those face cards, 6 of them are red, so we have 6 out of the 52 red face cards. So when we add these together, we got 26 plus 12 minus 6, that gives us a grand total of 32 out of 52. That is reducible. We can divide both of those by 4. That gives us 8 out of 13. So we have an 8 out of 13 chance of randomly drawing a red card or a face card. Now, as I said, we're going to kind of tie this in with complements. So recall from section 7.2 that the complement of an event with a probability P is all outcomes that are not in the event, and it has a probability of 1 minus P. You can use this to find the probability of a compound event. So we're asked to figure out this problem here. It says each of 6 students randomly chooses a butterfly from a list of 8 types. We're asked to calculate the probability of that at least 2 students choose the same butterfly. So the probability of at least 2 the same. That could mean 2 of them have the exact same one, or 3 of them, or 4 of them, or 5 of them, or 6 of them. That's it. But that seems like a lot of work. So I'm going to say the probability of at least 2 the same is going to be 1 minus the probability that they're all different. So instead of having to figure out a bunch of different probabilities, especially calculating each of those individual probabilities can be a lot of work. So we're going to do 1 minus the probability that they're all different, because then none of them are the same. So to start off, we're going to do the probability that they're all different. We got to first calculate the number of ways we can get all of them to be different. Divided by your total number of ways that they could choose. So the number of ways they could all be different, that's going to have to be a permutation, because if I go first and Mr. Way goes second, so I go first, I pick monarch, and then therefore if it's all different, Mr. Way can't pick monarch, which is tough because name another butterfly. I can't off the top of my head. There's like a blue tail, whatever, but I can't think of it. But it's a bigger difference if Mr. Way goes first and he gets to pick the monarch, and then I'm stuck trying to figure out what a different one is. So it's going to be 8p6 divided by the number of ways to choose all different. Well, if I go first, I've got 8 options, but if we can repeat so that they're all the same, it's going to be 8 times 8 times 8 times 8 times 8 times 8. Each person has 8 choices. Now, 8p6, there's a couple different ways you can do this. Without a calculator, you would do 8 factorial over 8 minus 6 factorial, all that over, well, the denominator we can just simplify as 8 to the 6th. Up top, 8 factorial, essentially it's going to be over 2 factorial, which means it'd be 8 times 7 times 6 times 5 times 4 times 3. All that divided by 8 to the 6. And folks, you can just type that into a calculator. It gives you about 0.0769. So the probability that they're all different is about 7.69%. So the probability that they're all at least 2 are the same would be 1 minus that 0.0769, which would be 9.9231. In other words, there's a 92.31% chance that at least 2 people choose the same butterfly, and let's be honest, it's going to be the monarch. This last problem is kind of similar. So in one day, 5 different customers bought earrings from the same jewelry store. The store offers 62 different styles. We're asked to find the probability that at least 2 of the customers bought the same style. So again, we're going to do the probability of at least 2 the same is going to be 1 minus the probability that they're all different. So again, instead of having to calculate what's the probability that exactly 2 people bought the same one, or 3 people bought the same one, or 4 people, or 5 people, that seems like a lot of probabilities. Let's just do 1. Now I'm going to kind of do this all in one fell swoop. Now we're going to do 1 minus, again, this is a permutation because if we're not allowing them to repeat, it makes a difference who buys what. So it's going to be a permutation up top. In this case, we got 62 different choices, and we're only allowing them to choose, or only have 5 people. Now, in the previous one, let me scroll back a second. The denominator here was 8 times 8 times 8 times 8 times 8 times 8 because it was 6 people with 8 choices, so it's 8 to the 6th. We're going to have 62 choices for each person, and there's 5 of them. It's going to be 62 times 62 times 62 times, oh my goodness. Folks, this looks tough, and it's doable by hand, but I'm going to show you how to do it on the calculator to speed things up a little bit. So let me jump to the calculator. There is a way to do permutations on our calculator, and the way we do that is we go to the math option again. We looked at column PRB before for the factorials. You'll see option number 4 is factorial. And you'll see option number 3, it says NPR. That's the permutation, with N being your group size and R being how many people you're choosing. You also notice there's a combination button below it we can also use. So I'm going to choose that, and I'm actually doing it wrong right now because it says answer first, NPR. Then it's, what you need to do is you need to enter in your group size first. So I'm doing 62. We're choosing from 62 options, and then we're going to go to NPR. So again, math, PRB, and then option number 2, and we're choosing 5 of them. So this is the number of ways that 5 people could choose 62 or choose from 62 items without repeating. The order makes a difference. Now, that's a lot. And on our work, we're asked to divide that by 62 to the 5th power. That makes it a little bit smaller. But that's how many different ways, or what's the probability of doing it all differently. So this is the 62 NPR5 divided by 62 to the 5th. And again, we got to do 1 minus that number. And it's going to give us 0.1524. Let me write that down, and we'll jump back to the notes. 0.1524. And again, that is rounding, because otherwise we'd have a really, really long decimal waiting for AirServer to pop back up. There we go. And so that gives us about 0.1524. In other words, it's about 15.24% chance that they all selected a different item. Nobody got the same jewelry that day.